Hello and welcome. This is going to be the second video on linear programming diet optimizations, and we're going to be looking at a second example. So let's get right into it. A salesman needs to sell 20 units of product A and 40 units of product B in order to meet his monthly goals. The salesman has to choose between a city and a town to sell both products to. The salesman can sell 5 units of product A and 2 units of product B per day in the city, and can sell 1 unit of product A and 7 units of product B per day in the town. Help the salesman meet his product requirement in as few days as possible while meeting the requirements given. It's a little redundant in the questioning, but we'll first look at how this is a diet optimization problem. As you can of course tell, we are minimizing days while meeting these requirements. So it is a diet optimization problem. Now we can first start off by, since putting this in a more visually appealing manner, by creating a table. So we're going to start with what we know is product A, product B, city, and town. So we can go through and see what these values are. This will make it easier to solve the model later. So you know that you can sell 5 of product A and 2 of product B per day in the city. And you can sell 1 of product A and 7 of product B in the town. So this is going to be our table. And now we can start with our objective function. This is, of course, as we wrote up here, we're minimizing the number of days. This is the number of days worked by the salesman. So we're going to set that equal to Z. And we're going to come back and define Z later. We're going to also have to make our decision variables. We have to be a little careful in how we formulate them so we don't run into any issues. We're going to define C and T. This will be the number of days worked in the city, and this will be the number of days worked in the town. So now that we have that, we can actually find out the minimizing the number of days is actually adding up the number of days worked in the city plus the number of days worked in the town. So that's how we're going to minimize the number of days. Now we're going to have our constraints. Subject to, this will be our constraints. And this will be pretty simple. We know that we need to sell 20 units of product A, at least. So this is going to be greater than or equal to, because we need to sell at least 20 products. The number of days spent working in the city will be multiplied by the number of product that we can sell. So that'll be 5. We'll have this, the same thing, but for the number of towns multiplied by 1. We're getting these values from the table that we set up right here. Now we're going to go for the product B constraint, which we need to sell 40 units of. It needs to be greater than or equal to. And in the city, for the number of days we work, we can get 2 per day. And then in the town, we can sell 7 per day. So now we have the 2 constraints for the products that we are going to sell in the 2 cities, in the city or the town that we can go to. And of course, in every single linear program, we need to add the non-negative. So our decision variable C and our decision variable T must be greater than or equal to 0. This is a little bit of a simpler problem than the one done in the last example, but it's important because no table is given, but you can always make your own table. Thank you for watching.